The new section is entitled Overlapping Triangles. There's really not much new here, but we should look at it. If you have two triangles that are kind of on top of one another, suppose you have two triangles on top of one another, A, B, C, D, and E. And to be clear what the two triangles are, we have triangle ABC, the left triangle, and BCD, the right triangle. BCD, the right triangle. Move this a little bit closer. BCD, the right triangle. Okay. And we are told some things about this triangle. That is, we are given that AB is congruent to CD. Length AB and length CD congruent. And AC is congruent to BD. And we want to prove that the triangles are in fact congruent. Triangle ABC is congruent to triangle BCD. This is what we want to prove. So we're told that AB and CD are equal. So I start off with one slash. Next two that are equal, if in fact there are two others that are equal or congruent, I'll put two slashes. And what do you know? AC and BD are congruent. AC and BD. So just keep in mind it's not EC and BE. It's the whole thing. Now we want to prove that the red triangle and the green triangle are in fact congruent. Well, when you look at the red triangle, you have one side with one slash and another side with two slashes. And this is true for the green, but two sides being the same length are not enough. For example, if one triangle has an inch or 3 inches and the other side is 4 inches and it's almost 180 degrees, well then the third side will be rather long. But now if you have the same, you have a triangle with a length of 1 and the length of 4, it makes a very, very small angle. Now this angle was kind of big. This angle is rather small. Well, this quite doesn't look as long as this one. So just because two sides are equal on two different triangles, and when I mean by equal, I don't mean that two sides both equal 8. One equals 3 and one equals 4 in one triangle. In another triangle, you have one that equals 3 and one equals 4. That's not enough. But you know what? BC is on both triangles. BC is on the green triangle and it's on the red triangle. So now I have two triangles that they have the exact same three sides. One has 3, 4, and 7, and well, 3, 4, and 6. Another triangle has length 3, a side of length 4, and a side of length 6. That is, both triangles have a side of one length 1 slash, another side of length 2 slashes, and a third side with an X, length X. So they're, by SSS, they're congruent triangles. So let's write this up. statements and reasons. Statement number 1 is the given, and the reason that the givens are true is because they were given. And now just jump right to it. BC is congruent to BC. The reason is identity. The length of a side is equal to itself. Now you can say right away that triangle ABC is in fact congruent to triangle BCD. And the reason is SSS corresponds, or it's congruent to SSS. And that problem is done. Try a couple more. One diagonal, second diagonal. Looks like a rectangle, but you never know. It's 2 diagonals. And you are given the following. G, H, J, K, and forgot that one. We'll call it F. You are given that angle FGH is a right angle. Okay? And that JHG is also a right angle. And you want to conclude, you want to prove, what's the V? You want to conclude that triangle FGH is in fact the same as JHG. You can lie them on top of one another. Okay. So first thing I would want to do with the student is say, oh my, which are these triangles? FGH. Draw the third side. That's one triangle. And the other triangle, JHG. That's the second triangle. I kind of blew that one. I didn't do it in green. Which really means I want to fix this up a lot. FGH. That's that triangle. And JHG. Almost picked up the black marker again. So it's the bottom left and the bottom right triangle that we're supposed to show are equal. Now we are given that FGH, angle FGH is the right angle. Start at F, go to G, and then go to H. This angle is the right angle. That angle is in the red triangle. The red triangle is the right triangle. JHG, J to H to G, that's the right angle. The green triangle has a right angle at H. Now, there has to be something else. How about I give you that FG and JH are the same lengths. This and this are the same lengths. Well, that's enough for me, because in the red triangle, I have a side. Okay, first let me comment on this. GH is in both the red and the green triangle. GH is in both the red and the green. So both triangles have an X, and both triangles have a side with one slash. Well, if you look at the red triangle, the angle in between the one slash and the X is a right angle. If you look at the green triangle, the angle between one slash and the X is a right angle. SAS. The angle's in the middle. SAS. So these two triangles, they really do correspond. Okay, so now all we have to do is write this up neatly. Okay, so statements and reasons. The first statement is what's given. You have to write it down as statement 1, 2, and 3 like some teachers insist. Fine. Statement number 2. GH is congruent to line segment GH. 2 is identity. The identity property. Well, that's it. Now you can say triangle FGH is congruent to triangle JHG. And the reason is side angle side corresponds or is congruent to side angle side. So these overlapping triangles, what they're probably going to give you, not every time, but probably more often than not, they're going to give you a common side. If they don't really give you a common side, well then you can kind of separate them and make them into two separate triangles. But the majority of the time, they're just going to be connected by at least one side. Let's try another one. That's the whole idea. Keep doing lots of these problems, then you understand how to do them even better. Suppose you have something like this. Suppose you have a figure like this. And we'll label it V, W, X, Y, and Z. And we'll call this angle 1 and that angle 2. And you are given the following. You're given the following. That YW bisects VX. And you're also given that angle V and angle X are congruent. You're also given that angle 1 and angle 2 are congruent. And you want to prove that ZW is congruent to YW. See here, you're not trying to prove that some triangles are congruent, but yet I suspect you're going to have to find two triangles. For example, maybe and no promises here, that VWY, that will be one triangle. ZWY is one triangle. This is what I'm suspecting. And that WXZ is yet a second triangle. Okay, we get the same diagram. Angle 1, angle 2. So I have a sneaky feeling that that's what's going on. Now, YW bisects VX. I have to think for a moment what that means. Okay, I was thinking that it was VW that bisects, okay, YW is this length right here. It bisects VX, that is, it cut VX in half. VX is this whole length. VX has been cut into two equal parts. VW, VX. So when it comes to the black triangle and the red triangle, we already have one side equal. Okay. Angle V and angle X are given to be equal. Angle V and angle X. You want to look here? Fine. They're given to be equal. And we are told that angle 1 and angle 2 are equal. Well, let's look at the left. In the left triangle, in the black one, let me just do one thing different. Since I already put one slash for angle V and X to be equal, let me put 2 marks for angle 1 and 2 to be equal. Okay. In the black triangle, I have 1 slash, and then I have a side with 1 slash, and an angle with 2 slashes. ASA. But I have the same exact thing in the red triangle. I have an angle with 1 slash, a side with 1 slash, and then an angle with 2 slashes. These two triangles are congruent by ASA. Now all we have to do is write them up. Now, possibly we don't even have to do that, but it turns out that the only way we're going to get these two to be congruent is to show that they're corresponding parts. Now, if you look at ZW, it's opposite the angle that has 1 slash. I'm just looking at the red triangle. I'm just looking at the red triangle. Let me write it down again. X, angle 2, Z, and W. ZW is opposite the angle that has 1 slash. Now, if you look at VWY, Y has 1 slash, and the side opposite is YW. So YW and ZW, they should correspond. In fact, they do. Okay, so now our whole job is to show that these two triangles are congruent, to write up the proof, and then to say that ZW corresponds to Y, is congruent to YZ by corresponding parts of congruent triangles being equal. Okay, let's see if this is going to be enough room. Statement 1, I put the 3 givens. Reason, justification, they're given. Okay, so since YW bisects VX, it bisects at W. We can say that VW in length corresponds or is congruent to WX. A bisector, a line bisector, cuts the line, don't know how to spell cuts. A line bisector divides or cuts a line into two equal parts. Line bisector cuts a line into two equal parts. Okay, and that's all I need. I now can say that triangle VWY corresponds to triangle WXZ, the red triangle. The black triangle is congruent to the red triangle. And the reason is angle, side angle is congruent to angle, side angle. And number 4, I can conclude what they wanted us to conclude, that these two sides are congruent. The reason is congruent parts, the congruent triangles, are actually congruent. Okay, that concludes this section. Do some more problems.